welcome you to the 37th lecture of Surface Mining Technology course, NPTEL online certification course. This is the second lecture on excavation by dragline, and in this lecture we will look into the excavation methods and pit layouts. So, let us, as we do in every class, have a glimpse of the learning background for the surface mining technology course. These are the learning objectives of the surface mining technology course, and these are the expected learning outcomes from the participants of surface mining technology course, and these are some of the textbooks and references. Now, let us look into the retrospect of the previous lectures. So far, we have covered the phases of mining. We have covered the different unit operations associated with every phase. We have covered the commencement of mining through opening of box cut, and we have covered the unit operations like drilling, blasting and excavation by shovel and dumper combinations. We have seen the blast free excavation systems using ripper and surface miner, and we have covered one class on the dragline, in which we have introduced the dragline. It has been found that dragline is basically an excavator which has the bucket suspended by the rope from the boom. So, the bucket basically suspended by two wires. One is hoisting wire, another is drag wire. So, the bucket is suspended from the boom through the hoisting wire, and this, if the hoisting wire is allowed to take up the bucket in the upward direction, it can lowered also, and when the bucket is required to fill, the hoisting wire allowed the bucket to be positioned at the toe of the bench. Then the drag wire is basically dragging the bucket towards the machine, and machine is standing above the bench. So, bucket is allowed to move through rubbing the face of the bench, and on that movement the loose material rock mark pile which is there after the blasting, that material is entered into the bucket, and by that way the bucket is filled. Then on filling the bucket, the machine is again hoisting up the bucket with the hoisting rope. By that time the machine starts rotating towards the dump direction, and on the dump direction the hoisting rope and drag rope, they position themselves in such a way, so that the bucket is discharged from the mouth itself and the material is dropped onto the dump. So, this is in a nutshell the dragline is working, that we understood in the videos and other photographs in the last class. And in this point, one is very important, that the bucket is always under the hoisting through the hoisting rope, and that is why there is no strong contact between the boom and the bucket, and that is why bucket is always oscillating, and that is creating the problem that the direct positioning of the bucket cannot be possible, and it is essentially required dragline cannot be used to fill any trucks or etcetera. So, it is basically dumping the material over an area. So, the actual control on the dumping and actual control on the or you can say not actual, it is the precise control on the dumping the material at a precise location is not possible with the dragline. Dragline is always go for the area dumping of the material, but because of it is having a very high reach, long reach, then the dragline is allowed to dump the material directly at a distance. If a shovel dumper combination is allowed for that, it is taking more time. Dumper is often compared with the stripping shovel. Stripping shovel, we have seen that stripping shovel is also just like dragline is having a large boom, but as it is a solid boom which is having the controlling unit of the buckets also. So, that is why stripping shovel boom reach is not as much as the drag line reach. So, that is the problem with the stripping shovel, and stripping shovel has to work from the bottom of the benches towards the upward direction, but stripping shovel has the facility it can dump the material at a precise location, not like drag line. Drag line dump the material over an area, but the cost of the drag line is lesser than the stripping shovel. It can operate with the very high specification, as the bucket is wear suspended, it is digging depth is significantly high, and also it the power requirements are lesser than the stripping shovel. So, these are the facilities of the drag line we have already found in our previous class. Let us look into the objective of these lectures of 3 lectures of the drag line. To understand the application of the drag line, to understand the operation of the drag line, and to understand the cost and performance calculations of the drag line. So, we are in this lecture we will start the basically the operations of the drag line, but I want that you should observe this video. This is a YouTube video, a link is given. This video basically show you the view of the operator. You can see this is the operator, this is the bucket, you can see the drag rope here, this is the hoisting rope, and this now operator is basically working on this, and you can see the view of the operator from this, and operator is now using the hoisting rope lifting the bucket. So, now the bucket is lifted, operator is now rotating towards the direction of from which the material has to dig. So, this is rotating in the opposite direction where the bench is there. So, now you can see this is the bench from where the operator has to take the material. So, you can see the view of the operator. Now, you can see how the operator is can see it is now lowering, hoisting rope is now lowering the bucket, and it is now in the toe of the bench, and it is now taking the material. So, after taking this, it is now rotating. See, as it is wear suspended, the bucket is oscillating, it is always oscillating, you can see the bucket is oscillating. Now, you see bucket has started dumping the material for this area, and all this filling and dumping is basically controlled by the 2 wears, that is hoisting wear and drag wear. Now, hoisting wear is now again lowering the bucket, and now the bucket is lowered towards the toe. See, this is the toe of the bench, and now the drag wear is basically dragging the bucket for its filling. So, bucket size you can keep very large size bucket, and this large size bucket is allowed to fill, and that is why a little bit larger boulders are also can be accommodated in this bucket. Now, see the dumping is carried out over an area. So, that area dumping is very clear from this view. Now, let us understand how the drag line works. Drag line works with basically the casting works for casting the material, casting the overburdened blasted rock from its face to the dump yard. So, basically if you look into this figure, this is the bench. Before you deploy the drag line at this position, you have carried out different holes, drilled different holes here, and then you blast this portion and allowed the material to be dumped like this. Now, this is the after blasting, this is the fragmented material. Now, this material is basically taken and thrown at this dump by the drag line. So, in other way you can consider this is the fragmented boulders, these are the fragmented boulders, and these fragmented boulders are now taken by this drag line. After taking this one, drag line is rotating and dumping the material at this position. So, the material is dumped at this position. So, in a nutshell, drag line is working in general like this, and this method is called side casting. Generally, we are having two types of casting here. One is direct casting, another is side casting. Instead of having a casting like this, drag line can take the material from this place and dump at this place, that is called direct casting. And if the material is taken from this and dumping at this, then it is called side casting. In general, 90% cases dumper is the drag line is allowed to go for the side casting, because that is the best way a drag line can be utilized in a mine. So, in a nutshell, the simple way, a drag line is allowed to stand on a blasted rock mass. So, to stand on a blasted rock mass, then take the material and go for side casting it to the overburden dump. So, in side casting the maximum boom reach is utilized and gradually the complete material can be taken out. So, this is the simple casting or side casting in general followed for most of the bedded deposit operations like coal mining, etc. These are basically commonly used. In fact, some phosphate mines of Morocco also, they are also using drag line for casting, direct casting of the material, and this why this is very well applied, especially if in case of multiple seam for the lower seam, or if it is a single seam deposit, the drag line can be easily used. But there are some special cases where drag lines are utilized. Those methods we will discuss one by one. There are three special methods we will discuss here. One is extended bench method, second one is tandem method. In this we are having two, one is horizontal tandem method and vertical tandem method. In first case, in extended bench method, we use one drag line, we can use multiple drag line also, but you can use one drag line, but in tandem method we need to have at least two drag line for this operation, where the second drag line walks behind the first drag line. So, this is the way we do. Before going into the details of the extended bench method, let us first read out some of these points. This is where the overburden depth of panel width exceeds the limit at which the drag line can side cast the burden from coal. A bridge of burden can be formed between the bank and the spoil which effectively extends the reach of the drag line. So, basically extended bench method is allowed where standing on the bench drag line cannot have that reach to transfer the material. So, the blasted muck pile is utilized to extend the bench, and by this way we are extending the reach of the drag line. So, the bridge extends the bench on which the drag line is operating, and bridge is formed by the material falling down from the spoil and direct placement with the drag line. So, the bridge itself is basically formed by the drag line. Then to remove the bridge material from the top of the coal, it must be rehandled, and extended bench systems are adaptable with many configurations geometries, and working bench by chopping material from above the bench forming the bridge, then the bridge has to be removed it from the top of the coal. So, the first bridge has to be formed, then the material major portion of the material will be shifted from that extended bench, or that is bridge whatever is called, and then the bridge has to be removed from the coal top. So, this is the way the excavation is basically carried out. So, the steps are: first the material is leveled by a dozer or tractor after the blasting, then secondary drag line first strips the material near the high wall, then moves on to the bridge and rehandle the material. When two drag lines are used, in that case one machine must operate at the speed set by the second one, and mine design must be considered their respective capacities and assign their separate digging depth for the best applications. Otherwise, extended bench method is applicable for the one drag line also. The first drag line, if two drag lines are used, first drag line strips the overburden from the top of the first seam and coal is removed, then the small portion is dozed to the pit and secondary coal seam is removed, and in secondary drag line strips large interburden to the third and final seam and is removed, and extended bench system must be designed carefully in order to maximize the drag line productivity. Now, let us look into the details features of this one. There is another figure, sets of figures are available with this, we will go into this at a later stage. First, the blasting is carried out and the material is found like this available after this. So, first drag line is allowed and the key cut is carried out and the extended bench is made at this position. Then the drag line is positioned on this and take the material and send the material at this position. So, this is bench is extended and then the bench material is shifted. This is another figure of the same. So, now let us look into this figure. You can see this is the primary dump and this primary dump has to be first extended. So, first job is to excavate the key cut and extend the bench. So, the key cut at this position, the key cut has to be made and the bench has to be extended. So, that is the first requirement in the extended bench method. So, now let us look how it is carried out. So, now we can see the key cut is on progress. So, we are carrying out key cut now and the extended bench is made already and the secondary dump is prepared at this position. So, dump is complete, key cut is still incomplete. We are doing this key cut and we will continue this key cut until we are completion this one. So, now the key cut is complete, our bench is already extended, key cut is complete at this position, the bench is extended and now our we can see our initial position of the drag line was at this position. Now, our drag line is moved to the extended bench. So, the drag line is now on the extended bench, it is started taking out the other material and dumping the spoil at a larger distance. So, the dumping is start for the from the extended bench and the excavation is continued from this point. Now, we have you can see our main dump, we have completed its excavation from this new position and so in this case excavation is complete. So, the main excavation is complete and bridge has to be then handled. So, that is the next part. Now, the from here the drag line will return back to its position and it can take take out the bridge part and allow the material to be fit for the free for the next phase of operation. Next method is tandem method. In tandem method basically we are deploying two drag line. So, two drag line, the first drag line is basically taking the material and giving the material to the second drag line and the second drag line is finally shifting the material to the dump pipe. So, this method is two type, one is horizontal tandem operation. In horizontal tandem operation both the drag line are working on a same level. So, they are working on same level and this is the plan view of this one, this drag line and this drag line are working at the same level and this is these are the overburden dumps, these are the dumps. And you can see the first drag line, that is this drag line which is at this position and this drag line is at this position. So, this drag line is taking the material and dumping at this position. So, this drag line is taking the material from this place and take the dumping the material at this place and this drag line is taking the material from this place and shifting that to the next phase. So, this is the way the horizontal tandem drag line is working. First drag line is taking the material for the second and second drag line is basically rehandling that one. So, this is the horizontal tandem method. This is the horizontal tandem method using which the muck pile is basically transferred. So, in horizontal tandem method once again you look the both the drag line are standing on the same bench, both are standing here and the drag line and drag line 1 and drag line 2, these are two drag line 1 and 2 and this one is for 2, this one is for 1. So, this 2 is basically taking this one material, giving that to the first one is shifting that one at a further distance. So, this is the exposed coal, this coal is being exposed by these two drag line gradually and the material is being shifted at a longer distance, at this case which is this reach is not available with the drag line 2, but this is available with the drag line 1. So, this is the way the horizontal tandem method is working, and that is why the this drag line capacity must be matching with the capacity of the drag line of the first one, otherwise this will be in some problem. So, in horizontal tandem method there must be two drag lines. The leading drag line is deployed on the high wall side to provide the key cut towards the high wall, and on completing the key cut this drag line excavated the first cut, and after excavating these two cuts the leading drag line again moved to the new key cut position ready for the next stripping cycle to repeat the sequence. And the lagging drag line, that is the drag line number 2, staggered at least 200 meter behind, or this is depending on the reach, behind the leading drag line, and sat on the spoil side of the extended bench formed by the leading drag line, and then the extended bench, whatever casted overburden is there, it has to lift that and move it out at a greater distance. So, this drag line excavate the first dig on the remaining portion of the stripping bench and also rehandle the loose overburden finally exposed to the coal seam fully as per the design is made. The similar operation can be carried out in vertical tandem method also. In vertical tandem method, the first one is standing on a upper elevation, the second drag line is standing on a lower elevation. So, the first one which is working at this position is basically taking the material and moving it towards the second one which is at a lower elevation, and basically it is dumping that material to a longer distance. So, it is basically giving from the upper to a lower one, and this lower one is basically taking that one and removing that to a longer distance. So, basically this is carried out for maintaining this height of these benches, and that is also depending on the quantity of material that has to be shifted from this point to this point. So, these are basically some important aspects. Vertical tandem method is similar to the horizontal tandem method. The same material is basically rehandling by the second drag line. So, actually the overall performance is basically the rehandling, additionally rehandling has to be considered in this case. So, in order to remove very thick overburden cover in the form of say 42 meter bench height or something like that, the vertical tandem method is practiced, and this is illustrated in the figure, and this high benches divided in two vertical benches, and upper bench and lower bench are basically considered here. Upper bench height is kept a little bit low and lower bench height is kept little bit more. And the first drag line seated in the upper bench and cuts the material in the decoiled area, which is basically by the extended bench method we establish, and after sufficient advancement the second drag line, which is having a little bit larger capacity, is deployed on the lower bench on the excavated side, and first dig operation and subsequently march towards the spoil sheet has to be carried out and finally fully exposed the coal seam. So, this is the vertical tandem method, which is basically allowing the drag line to work on a very high bench up to 42 meter, and that is allowing the vertical tandem method of operation. So, these are the references. Thank you.